More than 31 years ago, the Hubble Space Telescope was launched alongside 5 astronauts aboard the space shuttle Discovery.
With the Hubble Space Telescope, our window on the universe.
Did the engineers and astronomers at NASA know that it would become one of the most productive observational tools in the history of humankind? Did they think it was capable of inspiring some 18,000 scientific papers in just over 3 decades of operation? Hubble painted a brand new picture of space, one replete with supermassive black holes and a mysterious phenomenon known as dark energy. Where black holes had been a thing of science fiction and speculation, Hubble brought them to life, cementing them in the picture of our universe. It even helped to determine the age of the universe. Whereas before we could only guess that it was anywhere from 10 to 20 billion years old, the telescope revealed just how many years had preceded humanity, and just how many years had led up to this single moment in time, 13.8 billion. Yet Hubble cannot last forever. Official funding for the instrument was reported to end in June of 2021. And if not boosted, it is estimated that during the 2030s, Hubble will have experienced enough atmospheric drag to descend down through Earth's atmosphere, eventually crashing into a remote and watery grave. At the very most, experts assume Hubble will have 5 more years of functionality. However, new investments could see orbital boosts for the telescope, extending its legendary service further into the future. As Hubble seems to near the end of its mission, we welcome a new era of astronomical tools opening doors Hubble never could. One in particular, the largest, most complex telescope ever launched into space at 100 times the power of Hubble, is bound to change our understanding of the universe forever. The project has evolved tremendously since it was first conceived. It began as a modest telescope set to launch in 2007 and expected to cost just $500 million. 30 years of development and nearly $10 billion later, it's clear the James Webb Space Telescope, or JWST for short, has far outgrown its initial design. Now, it's not only the most complex instrument ever to launch into space, it is also one of humanity's greatest feats of engineering. The JWST is not, however, meant to replace Hubble. The two are meant to complement each other by observing different parts of the electromagnetic spectrum. While we can observe the visible light portion of the spectrum, Hubble was adept at seeing in the ultraviolet section, and Webb is built to see primarily in infrared, both of which are invisible to the human eye. Webb will see this part of the spectrum in great detail thanks to 2 main components: the tennis court-sized sunshield and the stunning 6.6 meter or 21 feet 6 inches gold and beryllium mirror. Beryllium is both a durable and light material that, when covered by a thin layer of gold, allows for better reflection and easier examination of infrared light. As its name implies, the sunshield is meant to keep observational tools from reading infrared light from the sun, but in order to detect faint heat signals from very distant objects, the telescope must be kept extremely cold. Blocking the sun's radiation means the instruments can continue to operate at around -400 degrees Fahrenheit, which is around -240 degrees Celsius. While the sunshield is vital to JWST's data gathering, it's also one of the biggest sources of concern. Thousands of parts, including 8 motors and 139 actuators, must work perfectly in order to unfold 5 membranes of the sunshield in space without any help from astronauts. Webb's final resting spot will be the L2 orbital position at around 1 million miles or 1.5 million kilometers from Earth, which is about 4 times farther from Earth than the Moon. At this distance, the telescope's view won't be obstructed by the Sun nor the Earth, giving it a clear celestial vista for study. This view does come at a price, however. Webb will not be serviceable by astronauts, meaning we have only one chance to get everything perfect, unlike Hubble, which was able to be serviced by astronauts on 5 separate occasions. In fact, without one of these repairs, we wouldn't have the iconic Hubble images we all appreciate today, because the telescope was initially launched with a flawed mirror that returned blurry photos and wasn't fixed until 1993, nearly 3 years after its launch. So what exactly is it that the JWST promises us in return? The universe's first light. Hubble could see far and back in time, but not far enough. With Webb's infrared capabilities, we'll be able to see the very first stars and galaxies ever to have formed. Witnessing these primordial structures will help us better understand not only the development and beginnings of galaxies, but also their inevitable end. It is a time machine of both kinds, forming a picture of both the start and the end. Hubble's ultra-deep field image gave us the most detailed picture humankind has ever taken of space. In the image, small red dots represent old and distant galaxies that have been redshifted by the expansion of the universe. Their light has been stretched into longer wavelengths as a byproduct of dark energy. But to see the oldest galaxies requires being able to capture even lower wavelengths than red light. It requires capturing in infrared light, a job that the James Webb Space Telescope is perfectly designed for. Scientists also expect that it will help us gather new information on exoplanets and the existence of alien life. In the cold silence of space, its clicking and whirring will beam back data on the worlds of our solar system, the worlds beyond it, and the budding stars and planetary systems forming deep within shrouds of cosmic dust clouds. It'll even peer at Sagittarius A star, a supermassive black hole at the center of our galaxy. Every phase after the Big Bang will play itself out in the data from JWST. The earliest stages of galaxy formation are expected to be especially interesting, revealing violent events billions of times brighter than the Sun. Although it's had many delays, Webb is currently set to launch in December of this year. After deployment, testing, setting up communications, and adjusting the craft, the first images from Webb should arrive around 6 months after launch. Once data from the telescope does pour in, we'll be seeing a new class of galaxies previously invisible to our instruments. Like any great tool, we hope James Webb will help us answer questions we haven't yet thought to ask. It is perhaps the closest we will ever come to travelling back in time and discovering the roots of our existence. I would like to say thank you to Ella Aldersons, who created the original article from which this video is based upon. If you want to read more articles from Ella, then click on the link in the description. Ella is an astrophysics student and writer with a passion for language and the unexplored universe. So head on over to Ella's page and immerse yourself in the many mind-blowing articles available. Thank you all so much for watching. Remember to like and subscribe, and I'll see you all next time.